Hey guys, in class I just went over the answers to last night's homework and told you guys that if you had any questions I would post a video on how to complete the problems. So that is what I am here doing. Alright, if you have not yet, I do encourage that you purchase a scientific calculator. It doesn't have to be super fancy. You can even check some out from the book room if they still have some available, like we have the TI-30Xs, but that is going to be helpful for you throughout the semester, as we'll be doing different calculations all semester long. So yesterday we talked about acceleration, and we talked about how the formula for acceleration was the final velocity minus the initial velocity divided by time. And that our end unit for acceleration should always end up in meters per second squared. All right. Give me just a second. All right, so our first question says, in 1991, 4 English teenagers built an electric car that could attain a speed of 30 meters per second. Suppose it takes 8.0 seconds for this car to accelerate from 18 meters per second to 30 meters per second. What is the magnitude of the car's acceleration? All right, so let's look for the information we know. We know here that our time is going to be 8 seconds. So let's go ahead and take our notes. Remember, step 1 is always take notes. So our t is going to be 8 seconds. All right, then we talk about acceleration, and we have some velocities here, 18 to 30. So our initial velocity, vi, is 18 meters per second, and our final velocity is 30 meters per second. Now we need to solve for the acceleration. So we don't know our acceleration at this point. All right, remember step 2 is to write our formula. So A equals Vf minus Vi divided by t. We're going to plug in our numbers. Our Vf we said was 30. Our Vi was 18. And we're going to divide by our time, which is 8. Once you do that, it's going to be 12 divided by 8 meters per second. When we reduce that, it comes to 1.5 meters per second squared. Remember, we write it meters per second squared, but it's the equivalent of saying meters per second, since we have meters per second divided by second here. So again, our answer, we circle our answer and make sure I put our units for our full points. Number 2, a speedboat is moving through the water at a speed of 28 meters per second when the engine stalls. As a result, the boat comes to a halt at 4.00 seconds. What is the average rate of acceleration for the boat? All right, so let's look at what we know. We're starting off with a velocity of 28 meters per second. So our initial velocity is 28 meters per second. All right, then we come to a halt because the engine stalled. So our final velocity equals 0 meters per second. Says it came to a stop. We do not have any velocity when we are stopped. Our time was in 4.00 seconds. We want to know what our acceleration was. Step 2, we're going to write down our formula, Vf minus Vi divided by t. I'm going to pop in the numbers. So our Vf was 0, our Vi was 28, and our time was 4. So we get negative 28 meters per second divided by 4. That is going to give us a negative 7 meters per second squared. All right, number 3. A race car moving initially with a speed of 15 meters per second is capable of accelerating at a rate of 6.0 meters per second. What will be the speed of this car after accelerating for a time period of 8.0 seconds? All right, coming through here, we're going with an initial speed of 15 meters per second. So we're taking our notes. Our initial velocity was 15 meters per second. And we're accelerating at 6.0 meters per second squared. And we want to know what the time period of our time here is 8 seconds. So we want to know what our final velocity will be. So our final velocity is our unknown. Go ahead and step 2, write out our formula. VF minus VI divided by T. And we're going to plug in what we have. We know we're looking for an answer being 6 there. All right, we don't know our VF, so I'm going to go ahead and put an X in there for now. Minus VI, which was 15, divided by 8. All right, now we have an algebra problem. So we got to solve for X, which will be our final velocity. Remember when you're doing, so what we have to do is we have to get this 8 to go away and come to the other side. So we multiply both sides by 8. That cancels that out. 8 times 6 is 48. All right, and we did 8 times X here. 8 times 15, which is 120. All right, that's our current equation. Now we're still going to try to get X alone, so we're going to add 120 to both sides. Because we do the opposite process, so this was negative, so we're going to add. 168 equals 8x. So now, because I'm multiplying here, we want to divide to get that away. So 168 divided by 8 equals, our x is going to equal 21. So therefore, our final velocity equals 21 meters per second. So there's a lot of shadow there, so let's see if I can lighten this up a little bit. Maybe have a little bit less shadow. Okay. Number 4. You are driving down the highway at a speed of 25 miles per hour when your car accelerates at 55 miles an hour in order to pass another car. What is your average acceleration of this car if this increase in speed occurs over a time period of 5 seconds? Now in class, I went ahead and gave you the conversions for the miles per hour, so that one makes it a tad bit easier. Remember, the 25 miles per hour was 11.2 meters per second. And our 55 miles per hour was 24.6 meters per second. All right, so let's write down what we know. We know that our initial velocity, coming first, is 11.2 meters per second. All right, and then our final velocity is 24.6 meters per second. All right, our time is 5 seconds, and we are wanting to know our acceleration. All right, we're going to write down our formula. A equals VF minus VI divided by T. Our VF was 24.6 minus our VI, which was 11.2, divided by 5. All right, that's going to be 13.4 divided by 5, which comes out to 2.68 meters per second squared. I guess that didn't really help with the shadow, did it? Oops, sorry about that. Turn on this another light. Is it gonna make it worse, or no? That's not really helping. Okay. Number 5. The driver of a car accelerates at -4 meters per second squared for 2.5 seconds. What was the original velocity of the car if it was traveling 17 meters per second at the end of the interval? All right, so we already know here we have our acceleration. So acceleration equals -4 meters per second squared. Our time was 2.5 seconds. All right, our original velocity is wanting to know. So we don't know that. But it says if we are at the end of the interval, we are at 17 meters per second. Let's write out our formula. A equals VF minus VI, so final velocity minus initial velocity, divided by time. All right, our A was -4. Our VF was 17 minus, again, we're looking for our VI, we don't know that. So I'm going to pop an X in that spot. And then our time was 2.5. Okay, so we have another algebra problem. So we're going to go ahead and multiply both sides by 2.5 because we are dividing here. We want to get rid of it. So that gives us -10 because we multiplied a positive with a negative, so that's going to be a negative answer. -10 equals 17 times 2.5 is 42.5 minus 2.5x. All right, still got to try to get this x by itself. All right, right now we have a positive 42.5. So since that's positive, we got to do the opposite process. We got to subtract 42.5 from both sides. I'm going to go ahead and come down here so I have more room. All right, so that means -52.5 equals -2.5x. Divide both sides by -2.5. Our x is going to equal 21 meters per second. And it became positive because if you remember, if you divide a negative from a negative, it becomes positive. All right, last question. The driver of a car accelerates at 4 meters per second squared for 2.5 seconds. What was the original velocity of the car if it is traveling 27 meters per second at the end of the interval? All right, so we have our acceleration here. Our acceleration equals 4 meters per second squared. Our time was 2.5 seconds. We don't know our original velocity, that's what it's asking for. And we know our final velocity equals 27 meters per second. We're going to go ahead and write our formula. A equals final velocity minus initial velocity divided by time. So our A equals 4. Our VF was 27 minus, we don't know our VI, so X, and divided by 2.5, which was our time. Same time. All right, so again, we're going to multiply both sides by 2.5. All right, this time we have a positive 10 because we are doing a positive and a positive multiplying here, equals $67.5. Let me calculate that one real quick. 27 times 2.5 equals, yeah, 67.5. Okay, 67.5. 67.5 minus 2.5x. Now we're going to, this is positive, so we're going to subtract the 67.5 from both sides, which gives us negative 57.5 equals negative 2.5x. Divide both sides by 2.5, negative, because we want to get rid of that. We're trying to get x by itself. That gives us x equals 23 meters per second, which is our initial velocity. Oops, let me mark that here. All right, that is how I did the homework. So hopefully if you made a mistake, so you see where you made a mistake at, and that this video helped you understand what to do next time. Until then, I'll see you later.